Hi, I am Ancy, Assistant Professor, Department of Biomedical Engineering from Emmanuel Arasar JJ College of Engineering, Nattalam. Today we are going to discuss about LVDT. LVDT stands for Linear Variable Differential Transformer. It is one of the major type of inductive transducers. It converts the linear motion into an electrical signal using an inductive transducer. It is used in many different fields. The LVDT is due to superior sensitivity and accuracy. LVDT used in computerized manufacturing, robotics, avionics and machines tools. These are the construction of LVDT. LVDT consists of single primary winding and two secondary windings wound on a hollow cylindrical former. The secondary windings have an equal number of turns which is identically placed on either side of the primary winding. This primary winding is connected to an AC current source whose frequency is between 50 Hz to 20 kHz. Types of LVDT. LVDT can be of many types based on their construction, size and specific applications. Here are some common types: AC LVDT, DC LVDT, miniature LVDT. Now we are going to discuss AC LVDT. AC LVDT is the most common and most used type of LVDT which operates on the principle of EMI. EMI means electromagnetic induction with AC as an input. AC LVDT are widely used for displacement measurement in various industrial applications. Then DC LVDT. This type of LVDT operates with a DC current input. This type of LVDT are used in limited applications where a DC power source is more convenient. Last one is miniature LVDT. This type of LVDT is small in size as the same suggests miniature and its stroke length is small but highly precise. There is sub-miniature LVDT also even smaller in size and best for limited space applications. This is construction. Already we discussed LVDT having two winding, primary winding and secondary winding. The single primary winding and two secondary winding wound on hollow cylindrical former. Secondary winding have an equal number of turns which are identically placed on either side of primary winding. This primary winding is connected to an alternating current source whose frequency is between 50 Hz to 20 kHz. Both the secondary windings have an equal number of turns and they are linked with each other in series opposition. Working principle of LVDT. The working of LVDT is based on Faraday's law of electromagnetic induction, which states that the electrical power in the network induction circuit is proportional to the rate of change of magnetic flux in the circuit. As the primary winding of LVDT is connected to the AC power supply, the alternating magnetic field is produced in the primary winding, which results in the induced EMF of secondary winding. Let us assume that the induced voltage in the secondary winding S1 and S2 are E1 and E2 respectively. Now according to using the rate of change of magnetic flux, that is d pi by dt is directly proportional to the magnitude of induced EMF, that is E1 and E2. The total output voltage E0 in the circuit is given by E0 is equal to E1 minus E2. In case 1, when the core is moving towards S1, the core is moving towards S1, Secondary winding S1, then the flux linkage S will be more as compared to ST. The EMF induced in S1 will be more than EMF of S2. Hence, E1 is greater than E and differential voltage E0, E1 minus E2 will be positive. The output voltage V0 will be phase with input AC voltage. Case 2, when the core is positioned at its null position. In the null position, both secondary windings will be same. The induced EMF E1, E2 and both the windings will be same. The net differential output voltage E0 will be 0. Then core moving towards S2. Moving towards winding S2 is flux linking with S2 will be more than SI. S1, it means EMF induced in S2 will be more than the induced EMF of S1. The output of LVDT, the AC voltage is proportional to the displacement or position of its core. The zero differential output voltage is produced when the core is in the center or null position, where the induced voltage in the two secondary coils are equal. Uses of LVDT. LVDT used in many industries and research, also used in medicine and patient monitoring system, etc. LVDT specification. The common specifications of LVDTs are linearity, sensitivity, resolution, electrical output, temperature range, etc. Advantages of LVDT. The LVDTs are high output, low hysteresis, low electrical noise, less power consumption. Disadvantages of LVDT. The LVDT is an inductive transducer. It is an sensitive to the magnetic field. It is an electromagnetic device also affected by vibration and temperature. These are the construction, working principle, disadvantage and advantages of LVDT. Then applications. Most commonly used in industries in the field of automation, aircraft, turbines, satellite, hydraulic. Then LVDT used to measure physical quantities such as force, tension, pressure, weight. Then LVDT plays important role in power generation as it monitors the critical components, turbines and generators. It is mainly used in geotechnical instrumentations as it is used for monitoring ground movement, landslides and structural stabilities. Thank you.